Hello, everybody. So we're getting into 4.4 today called compound inequalities. All right. So I guess first thing, go ahead and get this title, copy the definition of compound inequality in this example, and then we'll get into it. Okay. So it says a compound inequality consists of two inequalities joined by and or. All right, so there's two different types of compound inequalities. We'll be looking at both of them. I'll show you what they look like. Yeah, and it's basically just joining two inequalities together. So on this first example here, this, I guess the first thing to point out is an example of an and type of inequality. Okay, and after we graph it, I'll kind of show you why it's considered an and as opposed to an or. All right. So here's the thing. When they write and compound inequalities, they write them as one big thing, one big inequality. So we're going to go ahead and put these on our graph here. So we're dealing with -2 and 1. So on your graph, go ahead and let's put, -2 would be to the left, and let's see, we'd go -2, -1, 0, 1. Okay, and we can maybe add some more numbers like a 2, maybe a -3. Okay, it just kind of depends on the problem as to how many numbers we'll put on this thing. All right, so here is kind of the thing to realize. There's two inequalities here. There's -2 is less than x, and there is x is less than or equal to 1. Okay, the first one, the graph, and the easiest one is probably this one here. We know how to graph x is less than or equal to 1, right? So let's go ahead and put it on our graph. We know that that equal to symbol means at 1 there's going to be a closed dot. And we know when it's less than, that our arrow is going to be going to the left. I'm just going to do this for now, and you'll see why. Okay, so here's the thing about this inequality. It's flip-flopped. We want this to be, x on the left, -2 on the right. So the way we'd want to think about this inequality would be, actually x is greater than -2. We want to flip-flop this thing around. Okay, so on our graph, again, we know, okay, at -2, that means we have an open circle, and we know that the numbers that are greater than 2 on a number line go to the right. And you can see these two number lines are running into one another, and that is what happens on a quote-unquote and compound inequality. Okay, and basically what this is saying is that x can be any number greater than -2 and less than or equal to +1. Okay, so that's why it's an and. Okay, because basically x can be all of the values between these 2 points. Okay, so let's go ahead and try one that is considered an or inequality. An or inequality is really simple. It's not smushed together, or I should be using a compound inequality. But yeah, an or compound inequality is not smushed into one thing. It is just written as two separate inequalities. Okay, so this is saying that x is greater than or equal to 0, or it is less than -1. So on our graph, let's go ahead and put those numbers. So here's 0, here's -1. Let's put a few more. Here's 1, 2, -2, -3. Okay, so we just need to graph them, and that is our compound inequality. So x is greater than or equal to 0. That means closed dot, greater than goes to the right. Okay, and I am going to put an arrow on this. You'll see why. X is less than -1. That means that -1, x is less than going to the left. Okay, and this is the graph of an or inequality. Okay, so one thing is to point out, an and inequality, the arrows will always run into one another like they did on this first example. An or compound inequality, the arrows will always go away from one another. All right, and yeah, you can obviously see x would be all of these numbers greater than 0 or less than -1. It could not be any of these numbers in between. All right, so real quick, I'm gonna have you guys try a couple of these, and then we'll look them over. All right, so on number 1 here, first thing, let's get our numbers on the graph. We're dealing with a -1, and then we'll do 0, 1, 2, 3, probably enough numbers there. All right, we know this is an and quote-unquote type compound inequality. I should expect these arrows to go towards one another, but let's make some sense out of it. I always start with this one because it makes sense to me. X is less than 3. So that means open circle at 3, going to the left where it's less than. Okay, and then this, if we were to flip-flop it, would be x is greater than or equal to -1, right? So that means closed circle at -1, greater than goes to the right. And yeah, we end up with a graph that we expected. Okay, on number 2, here's the OR type of compound inequality. Let's get these numbers on. So we have a 7, and we'll just put 8, 9, 10. All right. And some of these, like if these numbers were super far apart, say we were dealing with like -7 and +10, I would not need you to put all of the numbers between -7 and 10 on your graph. You could just write those two numbers and then go from there. Okay, so x is less than 7, open circle, less than goes to the left. X is greater than or equal to 10, close circle, to the right. All right, so yeah, let's keep going. These problems aren't always as simple looking as these. These are already in the form where we can graph them. That's not always the case. So let's look at a problem where we need to do a little bit of work. Okay, so here's what we got. We have this x plus 5 in the middle here. All right, to be able to graph this thing, we need to have the variable isolated by itself. All right, and here's how we're going to do it. We're going to get rid of the 5 like we always would by subtracting 5. Okay, here's the thing. We need to subtract 5 from both sides of both inequalities. So not only am I going to subtract 5 from this side of this inequality, but I'm also going to subtract it from this side of the inequality. Okay, so a little strange, but this is how we got to do it since we've smushed together two inequalities. So it looks like we have a -3. We're not flipping, right? We just subtracted, no need to flip the inequality. 5s are gone, we got an x, and it looks like we have less than or equal to 4. All right, so on our graph here, here's a good example. So these numbers are kind of far apart. Here's how I'm going to do it. I'm going to put -3 here, +4 here, and I'm just going to show that 0 is in between them, just to give some context. Okay, that's kind of good enough for me. When you guys do these on a test, you'll have a number line kind of made for you already. So I'm not too worried about the amount of numbers. Okay, so let's start with this here. X is less than or equal to 4. That means closed circle, going to the left. Okay, and I know if I were to flip this around, I probably don't need to write it. I know this reads x is greater than -3, open circle, going to the right. Okay, so I'm gonna have you guys try one a lot like it. Go ahead and try it out. All right, so same idea. I need to get rid of this -5. We'll do that by adding 5. I need to do it to both sides of both inequalities. Okay, so it looks like I'm getting a -2. No reason to flip this. I just added a number. 5s are gone. I have x by itself, and it looks like I have less than 9 here. All right, so it's just like before. I'm going to put -2 here. I'm going to put 9 here. Show that 0 would land somewhere around there. And yeah, get this on the graph. I'm kind of going quick because you guys are probably starting to get the hang of this. So x is less than 9. Open circle goes to the left. Reading this backwards, x is greater than or equal to -2. Okay, and that means closed circle going to the right. Okay, let's keep going. They just get a little bit more complicated from here. Let's try an OR type here that requires a little bit of solving. This is literally just solving two inequalities like we've been doing in the previous lessons. Okay, so go ahead and take a second, copy this, and then we'll try it out. All right, so solving this first inequality, we know we need to first get rid of this +3 by subtracting. So I've got 2x is less than 6, and then divide both sides by 2, which, by the way, if you can do some of this stuff in your head, I'm not too worried about it, though we would probably want to be careful on inequalities with skipping steps, because if that was a -2, I'd have to flip, huh? So we might actually want to write them out just so we don't make the mistake of not flipping signs when we might need to. Okay, so there is one of our inequalities over here. It looks like we need to add 6 to both sides. Got a 3x is greater than or equal to 18. And dividing both sides by a +3. Again, no reason to flip the sign when we divide by a positive. X is greater than or equal to 6. All right, so we're dealing with +3. I'm going to put some numbers in between, 4, 5, just because they're so close together. 6, maybe some on the right and the left. And yeah, let's do this one. X is less than 3, open circle, going to the left. X is greater than or equal to 6, closed circle, going to the right. Okay, which is exactly what we should expect when we have an OR type of compound inequality. All right, cool. Let's keep moving. All right, so let's look at one that has quite a few things going on. So I have two numbers I need to get rid of to get y isolated. All right, we'll do it how we always do. So let's start with addition or subtraction first. Let's go ahead and get rid of 4 here. So I'm going to subtract 4 from both sides. Okay, but I need to also do it from this side of this inequality. So let's see, it looks like we're getting a 6. No reason to flip here. I need to bring down this negative 2y. Again, no reason to flip, and it looks like we have 20. All right, now I need to get rid of this negative 2. It's being multiplied, so I'm going to divide by negative 2, both sides of both inequalities. So divided by negative 2, divided by negative 2. All right, here's the thing. I just divided by a negative number. And if you guys remember, that means we need to flip our inequality sign. So that's the first thing I'm going to remember to do. I'm going to change this to greater than or equal to, and this as well. All right, so it looks like we're going to get a negative 3. On here, we got y, and on here, we have negative 10. Okay, if you guys notice, whenever we had these and type of compound inequalities, our inequalities were always less than, less than, less than, less than, less than, or equal to. Okay, same thing here. On this one, they're greater than or equal to, greater than or equal to. It's because this thing is actually not written in the typical way. Normally we put the smaller number on the left and the bigger number on the right, and that's not the case here. But that's okay. We can still graph this thing, though on a test, if you were doing like multiple choice, they would probably rewrite this thing as negative 10 is less than or equal to y is less than or equal to negative 3. They would flip-flop everything. Okay, so maybe just put that in your notes just in case, but really you can graph either one of these and you get the same graph. All right, so let's go ahead and do it. So let's see, negative 3 would be here. Actually, no, negative 10 is the smaller number, so that should be on the left. Negative 3 would be to the right of it, and then just to give some context, here's where zero would be. Okay, so let's see, y is less than or equal to 3. That means we're going to the left. We know that means that we're going to have a closed circle here, and this one's going to be going to the right. All right, so last thing, go ahead and try out one of these problems on your own. Okay, so yeah, a couple things to get rid of. First, starting with that positive 8, subtracting 8 from both sides of both inequalities. We have a negative 8, no reason to flip yet. 8s are gone. We have a negative 4x in the center. Again, no reason to flip. And it looks like we have, what, a negative 4? Okay, now we can get rid of this negative 4 that's being multiplied by x by dividing by negative 4, both sides of both inequalities. All right, and here's the big thing I'm hoping you caught. Dividing by a negative number means we're flipping our inequality. So that's the first thing I'm going to do. Okay, so it looks like I have a positive 2, x in the center, positive 1. All right, and just to do it again, normally the smaller numbers on the left, the bigger numbers on the right, it would normally be written like this. That means these would also have to be flipped again. Okay, so over on our graph here, we're dealing with a positive 1 and a positive 2. Let's put some numbers around it since they're so close. So 0, negative 1, 3, 4. All right, and again, I always like to start with this one, though we could start with either. X is less than or equal to 2, so close dot at 2 going to the left, and then this would read backwards. You know, I just want to make sure everyone's clear on this because I'm reading it backwards. I'm saying x is greater than 1, even though that's a less than symbol. Hopefully you know what I mean. If we were to flip-flop these, it would look like this. Okay, x is greater than 1, open circle at 1, and connecting our dots. All right, so yeah, compound inequalities, it's not really much more difficult than the normal ones. You just have to do a little bit more work. So hopefully you guys are feeling good on that. I'll see everybody in class. All right.